Okay, so you're establishing the relationship between charity and these independent variables. Now take note, this is not a cross-sectional data kasi panel data to kasi you have several individuals, 47 all in all, and then taken at 10 periods. So all in all, there are 470 observations. Okay, so this is a panel data. In fact, sabi ko dito, these are actual data statistics from the panel of individual tax returns, statistics of income sa US to. Find out the effect, if any, of these variables, lahat to, on charity. It's a balanced panel data kasi you have 10 observations and then you have 47 individuals. Okay? So, pwede niyong gamitin guys yung, okay, mamaya na lang ha, Ernest ha? Okay, yung ano, yung, sabi ko saying, meron pa ba nasa ano? Okay, mamaya na lang Ernest yung attendance. All right. So, you have the guide guys, you have the sample panel data, you have the video. So, ito yung ano, ito yung activity to nyo. When you post the your results sa folder, pakilagyan ng ang unahin nyo 1 muna no para alam ko na activity 1 yon, and then 2 activity 2. Make sure that you have also uploaded the data set, pero dito hindi na kailangan kasi ako nagbigay ng data set nito. Okay, so let's go now to our lesson. So I hope you have downloaded the RMD files. Naghahantong ano ko tong. Okay, what's this? Siya.
Hi, sir.
Yes.
Sorry. Paul po ito.
Mamaya na lang, ano, ha?
Okay po.
Okay, mamaya na lang yung attendance, ha? Okay, so let's open the, we were talking about guards last time. May mga hindi tayo na ano dito na ano, but I think it's really self-explanatory. So I hope on your own you will go through this. Siguro yung mga hindi pa na ano, maybe I can just record yung part nito na hindi pa na-discuss. Konti na lang naman yon up to model 6. I don't think na-discuss natin to. No? Yung may MA1 component. So this is MA. Ba't pareho to? Naulit siya. Yung AR1 component ba? Tapos na? AR1. Okay, MA1. And maybe for this one, we can make this as yung last model. Pakigawan lang to guys ng ARMA 1. ARMA 1. So this should be, yung ARMA order natin ngayon, 1 na to. Okay, with combined with GJR. Okay, our session today we're going to discuss VAR, no? Vector autoregression. So kindly open this RMD file. Okay, chat ko lang guys kung pause muna ako na, buksan nyo na ba? Okay, kindly chat na lang kung nabuksan nyo na yung VAR. VAR stands for Vector Auto Regression. I'll wait guys, kindly open, and then import na rin ng dataset na yung Y kasama doon, no? paki-chat guys kung na-open nyo na, ha? Para alam ko na, para I know when to continue. Pause muna. Okay, thank you for reminding me. Okay, so as I was saying, VAR ang ano natin, ano, vector autoregression. Tapos, multivariate to. Kasi pag iisa lang yung time series natin, ARIMA yung ginagamit natin, di ba? AR stands for past values of itself. MA, moving average, stands for past values of its error terms. Ngayon, vector na, ibig sabihin, several time series. So for VAR, we use multivariate time series. Ang ginagamit natin dito guys, ginagamit natin yung linear function of past lags of itself, past actual values niya, at saka past error terms siya, and past values of the other variables. So this is what distinguishes yung VAR with ARIMA. No? So, XT1, ito, XT2, ito, XT3. Ang sinasabi ko lang dito, there are 3 variables here, for example. Tapos gagamitin natin, in order to model X1, gagamitin natin si X1, pati si X2, pati si X3. Para i-model natin si X2, gagamitin natin si X2, past values niya, pati si X1 at saka si X3. Ganun din sa X3, guys. Okay? So, if you take a look at this one, guys, paki-open lang to, may gusto lang ako ipakita dyan. You'll be brought to this Penn State applied time series. You can also use this as a reference, also good reference. May ARIMA din dito. Sa ano nila, sa lesson number 11, pause muna ako, nakukuha niyo ba to? Hanapin nyo yung ano na to, yung online stat, andun sa RMD file natin. So it will bring you here to Penn State. Tapos time series to applied time series, and then you have these chapters. Paki-check nga guys kung nakuha nyo na, paki-chat na lang kung yes. And then we go here to lesson 11, yung VAR at saka arch. No? Yung arch, GARCH, na-discussan natin. Okay, thank you. And then our lesson today is VAR. Kung hindi natin matapos guys, and then siguro makapagsimula tayo ng VECM, Vector Error Correction Model. Andyan naman guys, may notes naman akong binigay sa inyo which you can follow. So sa time series guys, modeling, na ano natin yung ARIMA, yung GARCH, yung VAR, at saka VECM. I'm happy guys with the lessons that we were able to cover. No? Ma-cover natin yung dapat natin ma-cover. Alright, so here, kindly open this. This is a lesson 11 na to, yung VAR na to. Ito yun, no? I just want to show you the formula, guys. Ayan, no? The structure is that each of the variable is a linear function of past lags of itself and the lags of other variable. So ito guys, yun nyo, VAR1. VAR1 model. Ano yung VAR1 model? Okay, so we have this time series na X sub t. This is the first time series. This is the second time series. This is the third time series. Okay? Kaya sub t yan kasi guys, this is a time series. So this is time series 1, time series 2, time series 3. Now let's take a look at how this is modeled. So see, time series 1, tingnan nyo kung paano siya minomodel. So you have this one, phi 1, 1, x sub t minus 1 of 1. So ang ibig sabihin nito guys, you're regressing yung past value, log 1, order 1 ni time series 1 on itself. Pero hindi lang yun. Ginagamit mo rin yung past value ni time series 2 on time series 1, and then yung time series 3 on time series 1, plus a certain error term, okay, or epsilon sub t for series 1. Okay? And it's called VAR1. Bakit VAR1 guys? Kasi 1 log lang. Pag VAR2, edi magiging xt minus 2 yan, 1, xt minus 2, 2, and xt minus 2, 3. No? So gagamitin natin yung past 2 logs, log 2, yung order 2, in order to model your time series 1. Ito naman, time series 2, ganun din guys. No? If you notice, pareho lang yan. Nagkakaiba lang siya sa mga coefficients. Ito alpha 1, alpha 2, alpha 3. And then phi11, phi21, phi31, okay, phi12, phi22, phi32, etc. Okay? Pause muna ako guys. So far clear? Paki-chat nga kung yes. Clear ba so far yung structure ng isang VAR? Actually guys, kasi alam na natin yung AR1 model, madali na to. No? Nabago na lang siya, naging V, vector. Ibig sabihin ng vector, hindi lang isang time series yung ginagamit natin at saka model natin. Several time series. So kunyari, kung VAR2 ito guys, there will be 6 regressors here plus yung alpha 1 natin. Kasi madadagdagan to ng magiging phi11, phi21, no? phi21, xt minus 1 at saka xt minus 1 at saka 1. Magkakaroon ng phi 2, 1, tsaka xt minus 2 pala, xt minus 2 at saka 1. Kasi madadagdagan ng yung second order na lag. No? Okay, so that's VAR 2. Tapos pwede rin VAR 3, tatlong lags na. Okay, so in general, ang VAR P guys, order P, so this is the number of lags that we're going to include for the model. So another one guys is, aside from VAR, is VARMA. No? Ano naman yung VARMA? Kasama yung error terms niya. So parang arma lang siya. Tinanggal lang yung V. At dinagdag lang yung V pala. Kasi vector na siya, you are now modeling several time series using the values of the past values of the other time series to model a particular time series. Okay? So yun ang importante doon. Then guys, I will leave you to practicing nyo to, no? You can run this on your own, i-run nyo siya. Pwede nyo naman makopy yung code nito, yan. Copy the code. Alamin nyo lang kung saan nakuha yung mga data. Just read kung saan nakuha yung data dito, anong ginamit na data. Kasi ito, meron tayong temperature, mortality yata, at saka I don't know what these data are. Pero just to take a look at this, guys, tingnan nyo to. No? So this is a VAR1 model, VAR1 with trend. Okay, so here we are modeling yung isang time series si temperature. Tatlong time series kasi dito, no? Si temperature, si mort, tsaka si part. I'm not so sure kung ano yung mga time series na yan. Pero take a look at the model for temperature. Temperature at so minodel nito sa madali to guys, no, sa VAR lang, no? So you're using the VAR function. Dati ano tayo di ba? Auto.arima. Ito VAR function. So you're modeling that. X is your data consisting of your 3 time series. P is equal to 1. Okay, P is equal to 1. Ito yung order ng lag. So kung var 2, di 2 to, and then type is equal to both. Okay, so tapos ito yung naging result, no? If you take a look guys, yung si temperature, ang ano natin, ang regressors niya, temperature lag 1, so this is your T-1, no? C-mort lag 1, part lag 1, tsaka constant at tsaka trend. Okay, so all the variables are significant. All the parameters are significant. So when you write this, ito yung magiging model niya, no? Temperature is equal to yung constant ni 67.586 minus yung trend, may trend component siya, 0.007 minus 2.44 mort T-1. No? Tapos temperature itself, T-1 din, at saka part T-1. So that's how a VAR, vector autoregression model, looks like, guys. No? So may model din tayo para sa M, may model din tayo para sa P. Okay, VAR will generate all this. Andito ang pinakita lang yung isa, no? Pero yung complete na output niyan, guys, yung tatlo. So you can easily write the equation. So ito naman, P is equal to 2. No? So 2 lags, no? Lag 1 at saka lag 2. And you notice that not all were significant. Okay, so that's what you expect, guys, dito sa ano natin, sa modeling natin. Of course, guys, chine-check pa yan. Chine-check yung residuals as usual, no? Yung diagnostics natin. So back to our R model. Okay, so ito yung ano natin, basic steps, no? You plot the time series. I-check muna natin, guys, kung stationary siya, no? Ano ibig sabihin ng I0? I0, guys, di ba integration yan? Ibig sabihin ng I. Pag I1 kasi, dinifference yan. Okay, so dapat, sa I0 niya, guys, dapat stationary na siya. So determine the optimal lag length, estimate the model diagnostic test. Then we will have to look at ito yung mga bago sa atin, ano? Gringer Causality test, impulse response function, forecast error variance decomposition. Ang complete name niya FEVD, or forecast error variance decomposition. Okay, and we have the vector autoregression forecasting. All right, so first, guys, let's ang gagamitin natin ng mga packages, yung URCA, VARs, ito yung pinaka-importante sa atin, and etc. Okay, so i-run muna natin to. If you haven't installed a particular package, paki-install na lang. Okay, I'll give you a few more minutes. Pag okay na, guys, pag tapos na yung ano nyo, yung pag-install, paki-chat na lang kung yes or no tayo. Some of those packages we have already installed before. I'm not sure kung si Plotly ba na ano na natin dati. Stargazer, yes. ReadR, oo. Okay, so okay na yung pag-install ko. Okay na, guys? Paki-check kung na-load nyo na. Okay. Alright, then ano, guys, import na yung y.csv file that I sent you dun sa Canvas din. Okay, so import dataset. Text siya. Sa akin nakalagay siya dito sa, okay, it's here sa I just get it, FINTSAR class. Nasa var. Okay, y.csv. So that's the heading. Yes, may heading siya. Okay. May heading siya. Import. Make sure may heading siya guys kasi pag hindi, magiging part of the data set natin si ano. Okay, so you have here two data sets, two time series, Y1 at saka Y2. Simulated tong data na to para just for our purposes, no? But ang suggestion ko guys, mag-practice kayo kunyari dun sa ano sa quant mode, kunyari kunin niyo yung vector autoregression ng returns ni Apple, returns ni Google kunyari, returns ni si Yahoo. Pwede kayo mag-auto vector autoregression dun. Gamitin yung tatlong time series. You can do that guys kasi may pattern na naman kayo. So you can practice on that. Okay, so let's continue guys. So, check lang natin. Head. Okay. First 6 values and then last 6 values. 200 observations and then structure. So it's a data frame. Okay. Pareho sila numerical. Okay, summary. Si Y. Okay. All right. So i-plot muna natin guys yung time series. Now alam natin na ano ba yung class ni Y? Class. It's a data frame, no? Kailangan natin i-convert yan guys into a time series data kasi hindi mag-work yung modeling natin. We have to convert that into a time series. So let's start with Y1. Okay, time series. Okay, as TS na siya. Kasi numeric lang siya kanina. Yung Y sa data na Y, subset na Y1, start with, so it's from 2001, January 1, frequency 12. Ibig sabihin monthly data. Ganun din guys si Y2, convert natin siya time series from the data frame na Y, yung specific na column na variable na Y2. Again, start from 2000, month 1, frequency. Frequency is, okay. Run natin to. So kung titignan natin to guys, yung object natin na Y1. Okay, so it's now a time series, no? Time series na siya. Hindi na siya yung numerical. Time series na siya. Okay, so plot natin si ano si Y1. So how does Y1 look like? Autoplot Y1. Still running here. Okay, so this is Y1. Okay, sa tingin nyo guys, ano ba? Mukhang stationary ba siya? Okay, use the mic. Please quick answer. Does it look like it's stationary? Anyone please? Just unmute yourself. Yes or no? Mukha ba siyang stationary? Pakisagot naman please. Anyone? Alam natin yung characteristic ng isang stationary na time series. So does it look like Y1 is stationary? Okay, thank you Rondel. Yes, okay. You're correct, it's stationary. No? Wala naman siyang trend, wala naman siyang seasonality. So ganun din guys si Y2, tingnan natin. Kasi guys, hindi tayo pwedeng mag-VAR kung hindi stationary. Kailangan Remember, parang ARMA lang yan guys, AR. No? Pag AR, check for stationarity. Okay. Pag AR guys, hindi tayo pwedeng mag-AR process o MA or ARMA or ARIMA or ARMA kung hindi stationary. So autoplot din natin sa Y2. Okay, Y2 also looks stationary. So okay tayo. But we can we check that guys with yung ACF ni Y1 autocorrelation. Okay. So si Y1 okay, so meron siyang significant dito dun sa ACF niya indicating that this could be modeled as MA, no? Tapos yung PACF niya, yan, mukhang MA process to, no? Kasi walang significant, no? Ito yung sa time zero. Okay. Si Y2 naman, ganoon din guys gawin natin. ACF ni Y2. Oops. Mukhang may slow decay siya. Okay. So this is for determining kung anong possible na model na process ang gagamitin sa kanya. Si Y2. Okay. So mukhang MA, no? Alright. So first, na-check na natin kung stationary siya. Okay, pero may statistical test, guys. May statistical test para malaman kung stationary siya o hindi. We're going to use the ADF test. ADF test, I'm not sure kung nag-question, checking ko lang guys ha. Let me check kung galing siya sa time series na package. Okay, so here we're creating an object called ADF Y1. Then ginagamit natin yung package na T-series para sa ADF test, no? Augmented Dickey Fuller, naalala itong ADF test. Ginagamit natin si ADF test to check if your data is stationary. Ayan. Sabi, ano daw ang ano nito? Ang alternative hypothesis natin is stationary siya. Therefore, ang null hypothesis natin is not stationary. So ang null hypothesis natin, not stationary, p-value is 0.01. Therefore, conclusion natin, reject natin yung null hypothesis na not stationary yung time series natin. It is a stationary data. Okay, so importante to guys kasi pag nag-VAR na tayo, parang ARIMA din, no? ARMA o AR o MA process, yung Box-Jenkins na approach natin, kailangan muna stationary yung time series bago tayo makapag-model. Okay, so let's also, tama nga from the time series yan, no? From the T series. So let's check now for Y2. Okay, ganun din, no? Ganun din yung result. So both series are stationary. So if both series are stationary, then we can already determine yung VAR nila. Okay. So first, i-determine muna natin yung optimal lag nila. Ano yung ibig sabihin ng optimal lag? Ilang lags ang gagamitin natin para i-describe si Y1 by past values of itself and past values of Y2. Ganun din si Y2. Ilang lags? Is it T-1 ba? Or T-2 or T-3? How many lags are we going to use in order to predict or describe the variables? Okay, so from the VARs package, I have to check this. So, di ba pag may question mark, guys, lalabas dito yung sa help, no? Sa viewer ba? No results found. Di bali na. Nagra-run pa siya, no? So, let's create an object called lag. Tapos yung function natin, var select. Yan, no? Ito yung vars function. Okay. So var select, yung data natin is y. Then gawin natin ang maximum na log, no? 20. Usually guys, hindi naman umaabot talaga ng 20 yan kasi ibig sabihin pag may correlation yung data natin ngayon at saka 20 periods after, parang medyo it's highly unusual na 20 years after may correlation pa sa ngayon sa value ngayon. Okay, that's what that means. Okay, so sige, i-run natin to. Okay. So here we have hanggang 20, ano? Okay. Pipili tayo ngayon dito. Ano dito yung log selection na pinakamababa yung AIC, yung akaiki natin. Here, sinamarize siya na it's log 1 using AIC, it's log 1. Siya yung pinakamaliit na negative 0.61. Mas maliit siya kaysa sa log 2. Take note, yung log 20 guys, ang layo na, no? Ang layo na niya. So ang hinahanap natin, di ba, pag akaiki or yung Hanan-Quinan, Schwartz, ano nga ba yung FP, nakalimutan ko. But the lower, the better. So, turns out that it's just one log. Ano ibig sabihin nun? VAR 1 lang tayo. VAR 1 lang tayo. Or we can do this kasi may object na log na tayo. Log, then selection. Ayan. Okay? So, ang sinasabi dito na dun sa based on the VAR select, choose log 1. Okay, estimate na natin yung model. Since the optimal log is equal to 1, then we will have two equations. Ano ibig sabihin ng two equations? Two equations of one logs of each variable each. Diba ang minomodel natin dito dalawa, si y1 at saka si y2. So ang model natin for y1 is past value of itself t minus 1 at saka yung past value of y2. So ginagamit din natin si y2 para i-model si y1. One log lang din. No? Okay, so this is the command. So let's call it model 1. Okay, and it's vector autoregression, var. Our data is y. Log is at p is equal to 1. Okay, take note p to kasi var tayo. No? Kung MA to, di sana magiging p at saka q yung i-define natin. Type none, ibig sabihin walang mean. Okay, so let's run this. Okay, so we have now our VAR results. Okay, our endogenous variables are y1 and y2. Sample size 199. Log likelihood. And then, okay, estimation. Ano yung lumabas? So, sinabi sa atin ang model, y1 is equal to log 1 log 1 value of y1, yung prior value na t minus 1 to, pati yung y2 t minus 2. So ito yung model natin. So in order to model y1, magagamit natin yung prior value niya, 0.25. It's significant. However, yung prior value ni log 2, hindi siya significant. No? P-value is greater than 0.05. So we can only use the past value of itself. So lalabas to parang AR1 process lang siya. Okay, gets nyo guys? AR1 process lang siya kasi hindi natin pwede magamit yung value ni Y2. So hindi siya VAR. No? Yan ang sinasabi ng model na to. Remember, ang hinahanap natin dito, pwede ba natin magamit si Y2 in order to model Y1 also? It turns out na hindi pa pwede. No? Hindi significant si Y2. Y2 is not a good predictor of Y1. Okay, so tingnan naman natin si Y2 naman. Si Y2 naman, guys, tingnan nyo to, no? So, iba si Y2. Si Y2, pwede natin gamitin si Y1 para i-predict siya with the estimate of 0.58. Si Y, tapos si Y2 din, para sa kanya sarili mismo, significant din siya. So, iba yung si structure ni Y1, okay na si Y1 lang ang gamitin natin. Pero si Y2, makakatulong si Y1 para i-forecast si Y2. Okay, pause muna ako. Pause muna ako. Any clear ba so far? Paki-chat na lang guys kung clear so far yung concept na yun. Okay, thank you. I suggest guys that you go over this, no, yung kanina, yung itong sa sa Penn State, no? Kasi example niya dito, significant yung yung VAR, yung your other variables, other time series in explaining yung temperature. Diba? Nakuha niyo to, no? So this is a very good example of VAR. Yung sa atin, simple lang yung ginamit muna natin, and nakikita natin na iba yung model ngayon ni Y1, no? Si Y1, AR lang siya, no? Pero si Y2, both variables are significant predictors. Okay, so correlation. Okay, natin gagamitin yan. Okay, mag-VAR2 naman tayo guys. Mag-model 2 tayo. Again, you have the same data set. This is involving Y1 and Y2. P is equal to 1, var 1 lang. Type is equal to constant. Ibig sabihin may constant mean tayo. Sara natin to. Okay, with constant mean guys. Okay, si Y1 guys, hindi pa rin significant si Y2, ano? So, yung kanina walang constant walang constant mean. Ito ngayon may constant na. And sabi natin guys, kahit parang intercept lang to, no? Na kahit hindi significant to, pwede pa rin natin isama yan. Okay, so si Y2 naman, okay, ganun pa rin, no? Predictor pa rin si Y1 ng Y2. Although the constant is not. Okay, adjusted R squared nito, 0.53. 0.53. Yung isa naman, ang adjusted R squared, compare natin guys kung sino mas maganda. 0.5295. Itong isa, 0.5296. So, mas maganda tong pangalawa, a little bit, no? Konti lang naman yung difference nila. Okay, and then, side by side natin to. Side by side natin guys yung model natin using Stargazer. So let's check this. Okay. So here is a comparison of Model 1 natin at saka Model 2 natin. Okay. So for Model 1, parang kulang to. 0.249 at saka 0.590. 0.590, ito, sa Model 2 to. Tapos yung Model 1 natin, here, 0.249. Okay. Ito yung Model 1. Okay. So, as far as si Y1, okay, This is Y1, model 1. Y1 is a significant predictor of itself, but Y2 is not. Hindi siya significant. No? It's not a significant predictor. Si Y2 naman, okay, significant predictor siya sa sa kay Y1 at saka of itself. Okay. Pause muna ako. Ano nga guys, chat kung okay so far. Thank you. All right. So, which is the better model? Model 1 or Model 2? We can see from the adjusted R squared, 5% lang ang na-explain ito, samantalang ito 0.53. No? So, this is Model 2 is a better model. Okay. Then we go to diagnostic test. No? Ang diagnostic test natin, ang titingnan natin, serial correlation, kung yung mga residuals ba, related, autocorrelated ba sila? Hindi pa pwede kasi yung model natin, si residual at time t-1 is very correlated to time t-2 or time t-3, etc. So we can use this serial correlation. Ang null hypothesis natin, there is no serial correlation. So let's create an object called serial1, and then from the VARs package, we have this serial test. Ang i-check na lang natin guys si model 2 kasi mas maganda naman si model 2. So let's dispense with model 1. Okay, logs at 10, then type, we have to put this PT asymptotic. And then we generate the output. Let's run this chunk. Okay, meron ba? So we have this Portman, yung PT nga pala dito guys, Portman 2 test. No? So meron ba guys, ang data natin, yung residuals ng VAR object model 2. So yung mga residuals ba ni model 2, meron siyang serial correlation. Correlated ba yung residuals ng time t-1 sa t-2, etc. Answer is, p-value is 0.34. The null hypothesis is there is no serial correlation. Then, conclusion natin, we fail to reject the null hypothesis. Ibig sabihin, wala ngang serial correlation, which is good. Okay, which is good. So, okay tayo as far as autocorrelation is concerned. Yung residuals niya, guys, hindi nakaka-apekto yung residual ko at time t sa time t-1. Okay, wala silang relationship. Okay, so that's the first. Pangalawang diagnostic natin, no? So diagnostic natin is heteroskedasticity. Kamusta naman yung natin, yung residuals? Are the residuals homoskedastic? We would want the residuals to be homoskedastic, no? So ito yung natin, test natin. Ang gagamitin natin dyan, ARCH test, model 2, logs.single, pwedeng 12, pwedeng 10, kanina 10, ginamit natin. And multivariate ba to? Yes, true. So, run natin to. Okay. So, anong sinasabi dito, guys? P-value is 0.4032. Conclusion natin, we fail to reject the null hypothesis that the residuals are homoskedastic. So, okay tayo. We're okay with the residuals. And then we have, sandali kailangan maabot natin itong, pinapaste ko yung sarili ko kasi dapat umabot tayo sa IRF tsaka sa FEVD. Kaya abot tayo. Okay, so let's go back. Ang kagandahan guys ng GAR, kahit na 5 variables, pwede niyang pagsama-sama, no? Okay, so we're here. Okay, based on the arch test, no? Okay tayo sa variance, sa spread ng ano natin ng residuals. So wala siyang heteroscedasticity, okay? And third, you have the normality test of the residuals. Are the residuals normally distributed? So kamusta naman yung skewness ng residuals natin tsaka yung kurtosis? So dito may test tayo, no? Residuals are normally distributed. So let's call this object normal 1. Normality test ng module 2, multivariate. This is coming from the Yarkibera test. JB test, Yarkibera. Okay, so let's check. Normal 1. All right. So ito guys, JB test, Yarkibera test. Okay, kumusta naman yung residuals natin? Normally distributed ba siya? P-value natin 0.6221, ibig sabihin nun, we reject the null hypothesis that the residuals are, we fail to reject the null hypothesis. So normally distributed yung error terms natin. Pati yung skewed, no? Yung skewness. Okay? We fail also to reject the null hypothesis kasi yung normal distribution pwedeng makita natin through skewness also in kurtosis. So ganun din dito sa kurtosis, okay tayo. Okay? All right. Any questions so far? Okay, don't be too hard on yourself, guys. Talagang sa simula, medyo hindi naman kagad pag isang sitting lang fully grasp yung nakagad yung concepts. But it's important kasi compared to an ARIMA model, isa lang yung isang time series na to. Pag VAR, pwede nating tingnan yung impact ng different time series among itself. Kaya mga common dito guys, kunyari, ilang beses na ako nag-advise sa isang grupo 2 or 3 terms ago, ang paper nila effect ng Malaysian returns ng Malaysian index, sa Philippine index, sa Thai index, sa Indonesian index. Okay, so you're using several time series, no, yung returns nila tinitingnan. May effect ba yung mga returns na to among itself? So minomodel niya kunyari si Philippine returns, si PSEI returns. So imo-model mo yan based on past values of PSEI returns, based on past values of Thai stock exchange index return, Malaysian, Indonesian, Singaporean, etc. So yun, example ng VAR yun, vector autoregression. So pasok na pasok yun kasi gusto natin tingnan yung interrelationship sa mga time series na to among itself. No? So that was a thesis written a few 2 terms or 3 terms ago yata. So swak na swak guys yung VAR, no? Alright, so ito, okay, we will have to check kung yung coefficients natin guys, yung coefficients natin, asan ba yung coefficients natin? Di ba ito yung coefficients natin, balik ako dito ito, dun sa model ni Y2, okay, for Y2 series, ang value niya 0.59, ito yung contribution ni Y1 sa kanya, tapos 0.59 din contribution ni Y2 itself sa kanya. No? So ang tanong, how stable are these estimates? Pwede bang pabago-bago yung estimate na yan? Kasi pwedeng pabago-bago yan, guys, especially kung nagkakaroon ng structural break. Kunyari, yung data natin was gathered, let's say, from 2000, tapos kung tatamaan yung 2008, no? Very possibly, baka pwedeng magbago yung data. Kasi nga, nagkaroon ng global financial crisis in 2008. So pag gano'n guys, pag may potential na nagbabago tong yung estimate natin na to, ang tawag doon structural break. And you have to model that bago mag-GFC siguro, during GFC, and then after. Yun ang tinitingnan. Okay, that's what we call structural break. So we test that. Tingnan natin kung stable ba yung mga predictors natin. So this is the test, no? Check for stability of the model using eigenvalues and plots. So from VARs again, the function is roots. Roots, model 2, modulus is equal to true. So run natin to. Okay, ano ibig sabihin nito, guys? Ano ibig sabihin nito? What's the meaning of this? Eigenvalues yan. Okay, dapat guys, yung eigenvalues mo less than 1. So ang sinasabi nito guys na for y2, yung predictor natin na na kanina yung 0.59 at saka 0.59 din, no? Ibig sabihin yan guys, stable siya because the eigenvalue is less than 1. Pag greater than 1 yan, ibig sabihin yan, malamang may structural break. Kasi bakit hindi magiging stable guys? May happening, may nangyari. So ito, data to ng 2000, di ba? Year 2000. Hindi lang natin alam kung hindi yata umabot to ng 2008. No? Check ko lang. Kasi 200, tapos monthly, 12, hindi aabot. 12 times 8. Pwede, no? Pwede umabot. Pwede umabot ng kaso guys, simulated lang to yung mga values na to. Hindi to totoong values, no? Kaya wala, hindi natin ma-check yung 2008. Okay? That's left. I leave that to you guys. Pwede niyo check kunyari si Apple, si Google, si Microsoft, o si Intel, yung apat na yun guys, mag-VAR kayo. Tapos magsimula kayo sa year 2000 na data, no? 2000 na data, January 1, pwedeng daily, pwedeng monthly, tapos hanggang ngayon, no? Tapos i-check nyo guys kung kung makukuha yung data, baka wala pang 2000. Pero you try this with other stock prices. Pero returns ang gamitin nyo guys kasi ang stock prices hindi siya stationary. Okay? And try to see kung mayroong structural breaks. Siguro, tingnan ko kung I can give another example siguro on those prices. Okay? Check natin guys for stability. So let's plot this. Let's create an object, stability 1. Tapos yung stability nga, yung ano natin kanina, stability ng model 2, type is equal to cumulative sum. Then plot natin stability. Click natin. Okay. So take a look at this guys. Okay, so wala naman lumalampas sa red band nito. Pag ganyan guys, yung pag-plot natin ng cumulative sum, okay yan. Stable yan. Pag may lumampas dito sa red line natin, ibig sabihin, merong issue tayo with stability. Ibig sabihin, may portion dito na hindi na okay yung natin, yung coefficients. Kailangan i-model natin separately yun. So that's what we mean by stability. Okay. Okay, next. Ito na. Importante yung Gringer Causality. What's Gringer Causality? Si Gringer Causality, guys, this tells us that one variable, one time series, Gringer causes the other time series. So basahin natin definition na to. Y1, Gringer causes Y2 if a model that uses the current and past values of Y1 and current and past values of Y2 to predict future values of Y2 has smaller forecast error than a model that only uses current and past values of Y2 to predict Y2. Okay, ulitin ko So kunyari, gagamitin lang natin si Y2 para i-forecast o predict si Y2. Okay, so that's one model, no? In fact, ang tawag diyan, 'di ba, ARMA, no? ARMA, no? So ARMA lang tayo or gamitin natin si Y1, so magva-VAR tayo, no? Para i-predict si Y2. Okay? So, kung mas maganda guys, kung mas konti yung class, kung mas konti yung mas maliit yung residuals, kung nag-VAR tayo versus yung ARMA lang, then we say that Y1 Gringer causes Y2. Ibig sabihin, the introduction of Y1 as a predictor of Y2 is significant, no? So, ang sabi natin, si Y1, Gringer cause niya si Y2. And vice versa. Si Y2 naman, guys, kunyari, gagamitin na natin si Y1, tapos instead of just using Y1, in-introduce mo si Y2. Rinegress natin si Y1. Lumalabas na mas maganda, mas konti yung error terms, yung magnitude niya, kung sinasama mo si Y2. Then, our conclusion is Y2 Gringer causes Y1. Okay? Pag hindi, guys, then Y2 does not Gringer cause Y1. Okay? So, ginagamit natin to sa VAR, no? Sa vector autoregression nga kasi tinitingnan natin yung relationship ng mga different time series among itself. So in other words, Gringer causality answers the question, does the past value of variable 1 help to improve the prediction of future values of Y2? Nakakatulong ba si Y1 kung isasama natin as VAR na ngayon, no? Para ma-predict si Y2. Okay, yun ang sinasagot guys ng Gringer causality. Tapos meron pang isang Gringer causality instantaneous. Okay, pero mag-focus muna tayo dito sa regular na Gringer causality. Okay, kasi magta-time na. So, gusto lang natin guys, makita mo na tong tapos dito pakibasa na lang instantaneous, no? Halos related lang naman din sila. Okay, so ang natin diyan guys, Y1 ang pwedeng mangyari sa isang VAR kasi 'di ba pag VAR you have 2 or more time series. So, pag si Y1 lang, Gringer causes Y2, siya lang then that's what we call a unidirectional. Isang direction lang ng pag-Gringer cause. Or si Y2 Gringer causes Y1 and not vice versa. And not vice versa to. Lagay ko lang para clear. And not vice versa. Ibig sabihin, no? Si Y2 naman hindi Gringer cause si Y1. So unidirectional lang 'yan. Ganon din to, guys. Control C, Control V. Okay. Ganon din, guys. Si Y2 Gringer causes Y1 and not vice versa. Si Y1 does not Gringer cause Y2. Unidirectional yan. Now, if Y1 Gringer causes Y2 and Y2 Gringer causes Y1, in other words, they Gringer cause each other, then that's called bidirectional. Okay, sige, tingnan muna natin Check if does Y1 Gringer cause Y2? Okay. Tingnan natin yung model natin kanina, no? Nung predict natin si Y2, saan na si Y2? Yung walang mean. Okay, saan na siya? Okay, ito walang mean, di ba? Hindi significant predictor si Y2. No? Pero nung may mean na, yung model 2 natin, ano nangyari sa mean? Sa may constant na, no? Okay. May constant na. Si Y2, hindi pa rin niya Gringer cause si Y1, no? Pero si Y1, Gringer cause niya si Y2. Tayo dito? Okay. Si Y1, significant predictor ni Y2, this model. So we can say here that Y1 Gringer causes Y2. Pero let's test that formally. So ang code lang yan, simple lang. Gringer Y1. Ibig sabihin to, does Y1 Gringer cause Y2? So nakaka-affect ba predictor ba si Y1 on Y2? So tingnan natin dito ang code niyan from VARs, causality, model 2 guys, model 2. Okay, may constant to, no? Ang cause si Y1. So malalaman ko na ang tinetest dito natin kung Y1 Gringer causes Y2 kasi because of this cause. All right, let's run this. Run. Okay. Ano sabi dito, guys? Null hypothesis natin, y1 does not Granger cos y2. Okay, p-value. P-value, guys, practically 0. So, we reject the null hypothesis that y1 does not Granger cos y2. Si y1, Granger cos niya si y2. So, ibig sabihin nun, to better predict y2, isama mo sa kanya si y1. Okay? So, meron tayo dito instantaneous din. Okay, hindi ko na explain to. Instantaneous. Iba naman yung definition ng instantaneous. Pakibasa lang guys sa taas ano ibig sabihin instantaneous causality. Ang importante sa atin yung Gringer causality. Meron ding instantaneous causality. Alright? So does y1 Gringer cause y2? Yes, guys. Yes. Hence, y1 Gringer causes variable y2 means that the predictions of the value of y2 based on its own past values and on the past values of y1 are better compared to just using the past values of y2 alone. Okay, clear guys? Pause muna ako. So yung concept ng Gringer causality guys, gamit na gamit yan kasi lalo na pag nag-VAR kayo, kailangan nyo malaman yung Gringer causality. Clear so far? Paki-yes nga guys. Clear so far? Okay. Thank you. Okay. So, madali lang guys ang pag-test ng Gringer causality, but it's very important kasi gusto natin malaman kung si variable 1 ba, time series 1, Gringer cause na si time series 2. So, pag marami kayong variables guys, you can test, no? You can test. So, kunyari, 5 yung variables nyo. Tapos, ang cost nyo si variable 1. So, magbibigay siya ng result, si variable 1, Gringer causing variable 2, variable 3, variable 4, and variable 5. Okay, so tingnan mo na natin si H2 naman, si Y2. Does it Gringer cause Y1? So, let's create this Gringer Y2. Okay, ang difference nito, ang cost naman nito si Y2. Kanina ang cost si Y1, no? So, let's run this. Ano lumalabas sa Gringer? If Y2 Gringer causes Y1. Okay, null hypothesis, Y2 does not Gringer cause Y1. Look, ano sabi dito? P-value is 0.2345. Therefore, we fail to reject the null hypothesis that Y2 does not Gringer cause Y1. Kita naman natin dito yan, guys. Ito sa model 2 natin, di ba? Tingnan natin yung model 2 natin. Di ba ito? Where's our model 2? Okay. For Y1, guys, tingnan nyo. Significant ba si Y2 as a predictor? Hindi. So Y2 does not Gringer cause Y1. Okay? So, dun sa isa naman, Y1 Gringer causes Y2. Okay, tuloy natin, guys. Okay. So, are we better off using Y2 also as a predictor of Y1 in addition to past value of itself? No. No, guys, no. So, we need not use Y1 to model Y2. Pwedeng si Y2, pwedeng AR na lang yan o MA model, no? Hindi natin kailangan ng VAR as far as Y2 is concerned. Hindi natin kailangan na gamitin si Y1 para, sorry, are we better off using, baliktad ba ako? Are we better off using Y2? Also, tama to. Hindi natin gagamitin si Y2 para i-model si Y1. Okay. Okay, ito importante guys, no? Yung impulse response function natin, IRF. Okay, this is another important aspect of VAR, IRF, impulse response function. So what's IRF? Ano natin? So ito guys, IRF. Okay, IRF, impulse response function, computes the impulse response coefficients for VAR P, okay, or SVAR for n steps ahead. Okay, explain ko kung ano yung IRF na to, impulse response function. Okay, so let's create an object called impulse response function that's coming from VAR's package. So again, imo-model natin si model 2. Okay, impulse is Y1, response is Y2. Ano ibig sabihin nito? Ibig sabihin natin, i-shock natin si Y1. Ibig sabihin, ano natin siya, yung give it one standard deviation change, kunyari. I-shock natin si Y1, ibig sabihin, i-increase natin siya by one standard deviation. Ano mangyayari kay Y2? Let's take a look at 10 ahead steps. What will happen after 10 months, no? Kasi monthly yata yung data natin. Okay? Confidence interval, 95%. And kasi ang ginagawa dito, guys, bootstrap, no? Bootstrap. So uulit-ulit siya, iterate siya. So okay, i-run muna natin to. This one, impulse response function. Okay, so meron na tayong object na IRF, no? Okay. Kasi IRF1. Ito, no? So it's a list, no? Ito si IRF1. Okay, iba-iba yung laman niya. It's a list. Okay, then we go again to our VAR. I-plot natin para mas makita natin. So plot IRF1. I-label natin yung y-axis na Y2. Okay, so yung main label natin, Y2 responds to Y1 shock. Ibig sabihin, isa-shock natin si Y1, ano mangyayari kay Y2? Take note, guys, naalala nyo, does Y1 Gringer cause Y2? Yes. So since Y1, Gringer cause niya si Y2, baka may effect nga kung merong shock na ibibigay tayo kay Y1. So let's plot this. Okay, so this is the plot. Okay, let me plot this here para mas makita natin. Let me copy this, Control C. Gusto ko siya dito i-plot. Sa plots. Okay, run ko. Yan. Okay, this is the impulse response function. Okay, what does this tell us, guys? So pag shinak daw natin si Y1, ano mangyayari kay Y2? Okay, take a look at this. Yung red band na yan, that's your confidence interval, no? Ito yung point estimate, yung black. So ano mangyayari, guys, daw pag shinak natin ng one standard deviation si Y1, kasi di ba si Y1 Gringer causes Y2 eh. So magkakaroon ng effect yan kay Y2. So this is the start. Pag shinak natin siya, take note, no? After 2 periods, tataas, no? Tapos slowly, ano yung taas niya? Almost more than 0.5 eh. More than 0.5 yung effect sa sa Y2, no? Biglang taas ng mga 0.5. Tapos after 3 lags, after 3 days, 3 months, no? Bababa ng konting impact. Tapos slowly, liit hanggang wala na, no? Ito yung zero line, ibig sabihin wala na dyan. Clear, guys? Clear? So this is what will happen kung i-shock mo si Y1, ano mangyayari kay Y2? Remember that Y1, Gringer causes Y2. So if we shock Y1, this is what will happen to Y2. No? After 1 period, taas siya ng 0.5. No? Tignan niyo. Okay, so take a look at the explanation, guys. Okay. Sinulat ko na for your reference. No? At the initial period, a 1 standard deviation positive shock on Y1, okay, will lead Y2 to go up by around 0.2 dito. At 1, ito, kita nyo ba? Andito yung 1, no? So parang dito tataas si ano, no? Itong black na to, around 0.2, no? Thereabouts. Estimate ko lang yan, no? Kasi this is 0 at this is times 0. Then after 1 period, tumaas siya dito, no? Yan. Tumaas siya. Tapos after 2 periods, ang maximum niya dito, after 2 periods, tataas siya. So you can see the immediate effect of a shock of Y1 to Y2 after 2 periods. And suddenly, and slowly it will taper off. No? After 8 periods, halos wala na. On the 10th period, wala na. No? Okay, so nakita nyo guys yung, ano, yung importance ng IRF, Impulse Response Function. You're able to see what happens to your variable if the other variable is shocked. Ngayon, we expect something to happen kasi we know that Y1, Gringer causes Y2. Okay? So typically, to be expected in stationary VAR models. At around month 7, the effects of the shock today becomes insignificant. No? Kasi tumama na siya dito sa ano. Sa confidence interval natin, guys, dito, sa month 7, wala na. Remember, dapat hindi siya tatama sa 0, no? So at this point, 0 na yung ano, yung nasa confidence interval niya. Although positive pa rin siya dito, pero remember, parang dun sa mga estimates natin sa parameters, there's a possibility na maging 0 siya dito, kaya insignificant na yan. That's what that means, no? Okay? Alright. Now, tingnan naman natin guys si ano, ang impulse naman natin si Y2, tapos kay Y1. Take note, ako ang ina-expect ko, wala ito. No? Wala siya kasi, bakit wala siya? Kasi Y2 does not Gringer cause Y1 naman eh. Pero let's see. Let's plot. Let's run this whole chunk. Sino ko nagka-error? Too large. Sige, dito ko copy yan. Ayan. F1 yan. Ito. Control C. Control V. Lagyan ko lang ng space. Then run. Control Enter. Yan. Okay, tingnan nyo guys. Alright. So it seems na ano na may magkakaroon ng effect kay Y1. Okay, mali ba yung Y1 ko? Tama. Kasi Y2 does not Gringer cause Y1. So here guys, tingnan nyo yung confidence interval. Negative tsaka positive. Ibig sabihin nun guys, may probability na 0 yung value. So walang effect. Remember, ang titingnan natin yung lower at saka upper ng confidence interval natin. Lower, upper. No? So tumatama sa 0 line yan. No? So lahat dito guys, lahat ng impact sa Y1, it's all between a negative value and a positive value. So therefore, there's a probability na 0 siya. Okay? If you recall yung results ng regression, yung may upper at saka lower. Pag tumatama sa 0, di ba, between negative and positive value, insignificant yun. P-value is greater than 0.05. Okay, so, true enough, guys. Since Y2 does not Gringer cause Y1, we were expecting that the IRF will tell us that walang effect. No? Bakit walang effect? Di ba meron namang value yung shock? May value naman, di ba? Kunyari ito, 0.05. Yes, there is a value. However, guys, tingnan natin yung confidence interval natin. Okay, di ba? Yung confidence interval natin, between the upper and the lower, tatamaan si 0. Okay, so pag ganyan, guys, sabi natin, hindi significant yan. Okay, so this just confirms, guys, yung Gringer Causality test natin, no? Okay, last, itong FEVD, no? This is your forecast error variance decomposition, or let's call this FEVD. Okay. So let's create this object VD, FEVD. This is also from VARs, no? Model 2, 10 steps ahead. Then i-plot natin. Diretso na natin. Hindi na naman kumasya. Okay, dito natin gawin. Shift up. Shift up. Copy this. Control C. Control V. Control Enter. Run natin. Yan. Okay. So this guys is your forecast error variance decomposition. Itong decomposition na to, guys, tinitingnan natin yung effect ng other time series on the time series in consideration. Kunyari ito, FVD for Y1. If you take a look at this, guys, yung gray na to, that's Y1. Yung light color na to, Y2. Ibig sabihin dito, walang effect, no? For 20 periods, walang effect sa pag-explain ng variance ni Y1 si Y2. Compare that with this one. Ito. Tingnan nyo. FEVD for Y2. So you can see that over time, first period, ang Y1 dito yung gray, ano? Okay? First period, may konting portion dito na ina-explain ni Y1 si Y2. And then nag-increase siya ng konti dito, and then nag-increase hanggang consistent na siya. Hanggang dito na lang siya. So dito, guys, may portion dito na ina-explain si Y1 on Y2. Okay, yun ang forecast error variance decomposition. So parang percentage siya ng variance ng variable mo na kayang i-explain ng sarili niya at saka ng isang variable. So ito, guys, yung FEVD variance decomposition ni Y1, 100% lang kay Y1. So walang percentage dito ang kayang i-explain ni Y2 on Y1. Samantala dito, guys, no, sa simula, si Y2 lang, pero after one period, guys, anong nangyayari? Tumataas yung hanggang naging constant na siya. So si Y1 kayang i-explain a certain percentage, less than mga 30% or something. Ang variance, ang variability ni Y2 di kayang i-explain ni Y1. Okay, clear yan, guys? Paki-chat naman kung clear yung FEVD, guys. So I hope naging clear sa inyo yung Gringer Causality, yung impulse response function, at saka itong forecast error variance decomposition. Siguro magbibigay na lang ako ng isang example, guys, na gagamitin ko yung stock prices, yung returns, tapos sundan nyo na lang, no? Ipopost ko na lang yung ano na yun. Okay, clear? Okay, thank you. All right, very good, very good. So just to finish this, guys, may I have just 2 more minutes? Wala pa naman time, malapit na mag-time. Okay, thank you. Okay, balik ko na to. And then yung forecasting, guys, ito na, no? Yung last. So ito na yung variance decomposition natin. Of course, guys, ang importante, nag-ano din tayo, nagpa-plot din, no? Wait, forecast names GDP unemployment. What names ito? Forecast 1. Y1 ba ito? Let me check, guys, ang Y1. Y2. Okay. So we can do now forecasting. So let's create an object, forecast 1, predict, model 2, 10 steps ahead, 95 degrees, 95 confidence interval. Tapos ito, guys, yung fan chart, no? Ito maganda to, fan chart ng forecast 1. At saka, wala pa tayong forecast 2. Bakit forecast 2? Forecast 1. Okay. Alright, run muna natin to. I'll run this. So we now have a forecast object here, list of 4. Tapos i-fan chart natin nga, fan chart. Okay. So ito guys yung ano, yung forecast natin for the next 10 months, no? Tingnan nyo guys, ito yung band na to, ito yung ano, ito yung confidence interval. You can increase this, kunyari 24. Para to yan. So this is 24 months. Kita natin. And then also for Y2, ganoon din, no? Okay. Then yung mga forecast na yan guys, nasa ano yan, nasa object na FCAST1. Okay, so thank you so much guys. It's already time. Now, yung VECM guys, I hope you will read this. Yung VECM. Pareho lang naman siya guys ng VAR. Ang kaibahan, mag-vector error correction tayo kung non-stationary yung ano natin. Okay, it's just like VAR, guys. Kasi si VAR, di ba, stationary yung ano natin, yung series, yung mga series. Pag hindi na siya stationary, ito na yung gagamitin, yung VECM na. Vector Error Correction Model. And kaya nga dito sabi natin, no, may integrated na siya, may hindi ko nalagay yung equation dito. Anyway, ipapadala ko na lang. Tapos, andito din naman guys yung ano, ganun din siya. Ganun din siya, halos pareho din. Halos parehong-pareho din siya guys. Ang may kaibahan nga lang ng konti kasi ito, this is from the VECM data. Ang suggestion ko guys, follow this. Makukuha nyo to, no? Kasi may mga explanation naman eh. There are explanations. Tapos kung masundan nyo to guys, yan, may IRF din. Okay? May IRF din dito. Then we take a look at tatlong IRFs to kasi tatlong variables to, no? And then may variable variance decomposition din. Okay, so this is just a specialized VAR. Kaya nga sabi ko kahit hindi natin ma-discuss yan, kakayanin yan kasi in-specialize lang yung VAR na yan. Okay? So